Hello everyone, for project 1 of Dr. Osbay's class, we're going to be modeling a 2D wind tunnel in ANSYS for 20 Hertz. So to begin the simulation, we dragged over the fluid flow fluent and clicked on geometry. And here we are in the XY axis, and we're going to be using the constraints provided in the handout to model the wind tunnel. So here I'm doing the height of 22 inches. And then I'm going to go ahead and add a midpoint constraint so that the midpoint of the 22 inches is at the origin, just make things a lot easier for us. And then we're just going to go ahead and start building this thing. So we're starting out with the first segment. It's going to be 15 inches. Then we're going to do another line. This one's going to be 24 inches. Again, another line, 12 inches. And then our last line, which is going to be 42 inches. Now I'm just going ahead and adding some dimensions, make sure we have all of our lengths and widths correct. So we got that 22 inches, we got that 12, and then I'm going to go ahead and add a 3-inch dimension from the midpoint to the test section because it needs to have a height of 6 inches. Same idea here, adding more dimensions. We got the 15 and got the 24. Change it to 24. Then we got the 12. And lastly, our 42 inch. And what I'm going to go ahead and do here is add a dimension for angle. So we want to have a half diffuser angle of 3 degrees. So I'm going to go ahead and do this by doing 180 plus 3 degrees, which is 183 degrees. So we really made it easy for ourselves here by basing everything off of the midpoint. So we're going to use the mirror function to reflect all of these lengths to the other side. So then we have our full wind tunnel configuration using the mirror function. And here I'm just going to go and connect that so it's all one piece. Now we want to make this a complete solid shape so that it's all one. So we're just going to combine that. Here we go. Got our full wind tunnel. It's looking great. And now I'm ready to move to the next step. We're going to mesh it next, but I'm going to save this just in case anything happens to it before we do so. Now I'm just making sure that the geometry is all updated, and then we're going to be ready to start our mesh. So go ahead and open that mesh up. Then we're going to go ahead and select our geometry, select our shape, and we're going to change the method to triangular. Then we're also going to change the size to 0.01, just make it a little bit more precise. Then go ahead and generate that. Then once it's all generated, we're going to go ahead and name some things. So we're going to first select all the edges, and we're going to name this as the wind tunnel walls. And the next one, we're going to select that one inlet and then call this the wind tunnel inlet. And then same thing with the end. I think I called it exit, but I meant to call it outlet, but we're going to do a name for the wind tunnel outlet. So you can see we have our 3 names here. Now we're just going to make sure that everything is updated with our mesh. And now we're going to go into setup. Once that opens up, we're going to do solver processes and set that to 2 and double precision. Then when that opens up, we're going to go to models and energy and turn our energy equation on. Check that box, hit OK. Now we're going to select viscous flow, and we're going to set that to K epsilon, and then also going to check that enhanced wall treatment box. Also going to click that pressure and thermal box, hit OK. Then we're going to go ahead and select our boundary conditions, and for this, the velocity magnitude is going to be specific to each case. So for this case, we're doing 20 hertz, so using the formula provided by Dr. Osby, calculated that to be 1.2563764, if I'm reading that correctly. Now we are ready to initialize. So I'm gonna go ahead and click initialization and initialize. Now we're going to hit calculate on run calculation and see the values populating, the graph is going. We'll show that in a second. There we go. We have our first run. So now we can go ahead and run our simulation for each of the metrics that we want to calculate. But first we're going to go into contours, select our surfaces. And first we're going to do static pressure, run that one. And now we're going to go and change static pressure to dynamic pressure. Select our surfaces once again and run that. Now we're going to change, I accidentally did absolute pressure, but we're going to change it to total pressure. Run that one. There we go. And now lastly, we're going to change it to velocity. For our velocity case, run the velocity magnitude, and there we go. Now we're going to head over to plots, open the XY plot, and we're going to do a new surface. We're going to do it from 0 to that middle point, so that's going to be 2.3259. We can just call this center line. Create that, select it, and now we're going to do static pressure again. And then I go ahead and save the file at this point. Same as we did with the other, we're going to change from static to dynamic pressure. Select your center line, run that again, and then I'm going to go ahead and save this one as well. Same process, going to switch from dynamic pressure to total pressure. Run that again, then write file, save that file. And then again, lastly, we're going to switch from pressure to velocity, velocity magnitude, select our center line, do that, and then save my file again. And there you have it. 2D wind tunnel simulation complete.